Good morning. So today we are going to be working on our Centripetal Force Lab. And what we're going to do for today is we're going to measure the weight of our washers and the centripetal force of this rubber stopper when I start spinning it above my head. Now, if we do the lab correctly, what we know is that the weight of the washers pulling down and the centripetal force of the string spinning in a circle will be equal and opposite to each other. So if we take the mass, we can get the weight, and then we're going to take some data to get our centripetal force. And once again, if we do this correctly, the net force is equal to 0 because the string is going to stay in the same spot. It's not moving down, it's not pulling up, therefore the forces will be equal and opposite. Okay? So in order to do this, we're going to gather some data. So the first thing we're going to do is we're going to get the mass of the washers, and we'll use that mass to get our weight later on in this lab.
Okay, now notice that this is in grams, and you need to convert to kilograms.
Okay, and so that's the washers that we're going to use to solve for our weight. And this is the rubber stopper that we're going to use to put in our centripetal force equation. And that would be
12.2 grams.
And we're going to convert that, once again, you'll convert that into
Kilograms.
Okay, the next thing that we know is that when I swing this rubber stopper above my head, this piece of tape is going to stay the same distance above my head. So the distance will be about this far, the piece of tape will stay below the tube about this distance. So doing that, we know that this piece from here to here will be my radius. So we're going to lay it along a meter stick, and based on that, we can figure out what the radius is that it's going to swing at. So that will be the radius that I swing at.
Okay, and that's 75.5 centimeters. 75.5 centimeters, which you have to convert to meters.
Okay, and then we're going to use my stopwatch, and we're going to time how long it takes for 30 revolutions. Once again, if you look at the distance where the tape is going to stay the same distance below the tube right here, and therefore I know because the tape is staying the same distance that my radius is staying constant. So we're going to wait till I get this going, and then Mr. Fracchia will start our timer and time for 30 revolutions. All right, I'm going to slow it down a little bit. All right, that looks like a good distance right there, Mr. Fracchia. So you're going to start timing 30 revolutions, and you're going to count.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 26, 27, 28, 29, 30.
All right, and then we're going to stop it.
And our time is 17.19 seconds.
And that's the time for 30 revolutions. And now we can use our FC formula to solve for our centripetal force, and we can use our FG formula to solve for the weight. We're going to solve for it 3 decimal places when you get, so you're going to solve to the 100th place, thousandth place, and you're going to see how close they come to each other.